Okay, today we will see how we can do the PGP encryption and decryption in Delgumi. So first thing is what is PGP? It's a PGP is an encryption technology used for the encryption and decryption technology used for security purpose. Okay. 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 Now we will see the what exactly the PGP is and how we can do the encryption and decryption in Delbumi. So you can just do the PGP is basically here is pretty good privacy. It's a commonly used an encryption way. The main reason we will use encryption is to just for security purpose. So you can just look at this diagram how it looks like. You can just look at the how like what exactly happens in behind screen is. So first thing is we so we'll see what I'm not able to make it. Okay. So if you see, so the encryption is basically what exactly we'll do with encryption is converting the plain file into a non-readable format. So if you just send out an email or something like if you send out a file by opening the file content, right? So anybody can see the content what exactly are there in the file. But if you encrypt that file, right? So only the unauthorized persons can able to view the data. How we can do that encryption is one common thing what we can do is we can go for the PGP encryption. The Boomi direct input support option is there. So what encryption is basically is all the encryption happens is using the cryptography technologies. It's called basically key value pair thing will happen. So there is a two types of keys will be there. There is a two types of keys will be there. Public key. The other one is private key. So first thing is, first we'll see what happens is encryption and what happens for the decryption. So encryption is basically what happens is we are converting encryption nothing but converting plain data to encrypted format, non-readable format. It's something like maybe you can see binary format, ASCII characters will be there. We'll show you once you convert it. So for that this is a plain format. So for this, what we are going to use is you are going to use a public certificate. For encryption, you are going to use a public certificate. I'll tell you how to generate the public key and all the things on the POMI. So generally, when I say key pair, generally we call it as a key pair. As the name says, key pair in the sense it's a combination of or it's inclusive of public and private. Why do we need to use two keys? Why do we need to use two keys? So I don't want like generally what we'll do is whenever we want to encrypt a file, right? We need a public key. This is only used for the encryption. This is private key is required for the decryption. As the name says, private key, right? Private key is it's not meant for sharing it. So whoever is authorized person, whoever is the owner of the data, he should have the private key, and he should not supposed to share this key. Whoever want encrypt the data and give it to the owner, so he can extract the public key and he can give it that. So using the public key, he can encrypt the data and can give it. This public key, as the name says that, right? He can give any number of persons. Same owner can give for 10 customers the same public key. So there is no harm in that. All the 10 persons can encrypt your data, and only the only owner who has the private key can only decrypt it. That's the main for the why we are maintaining for the two keys. Key pair is just for whenever you want to share the key, right? So we need to always share the public key, because as the name public key is meant for, there is no harm in sharing that. Only public key can be used for encryption purpose, not for they cannot able to decrypt it out. Private key is only for decrypting purpose. So when I say key pair, in the sense it's a combination of public and private key. So even in a private key from key pair, what we can do is we can extract the private from private key. Even we can extract the public key as well. Extract the public key as well. I'll tell you how we can identify this public key and this private key is corresponding to a one key pair. Is basically there is an fingerprints will be there. There is one unique ident random number will be there that will be correlated. That would be the same for public key and private key. It means if I have generated two key pairs, each key pair will have own unique ID for fingerprints. So if the one public key and private key fingerprints are matched, nothing but it's a one key pair. Okay, I'll tell you where to see all these things. So let's see what happens when I say encryption. What happens is when I say decryption, what happens is, let's say this is your actual file. Okay, this is your actual file. Where is that? 1 second. Okay, so when we have an actual file, when we use the encryption public key, so public key, what it will do is public key will generate one key, random key. See, in olden days in convention, right, what we will do if you want to encrypt something, right, we will use some kind of one a key. Maybe key can be a number, random number, or it's a static number, it's a combination of some number, or it's shuffling some characters. But all the thing is you need to, anyone can easily guess and they can decrypt and tamper the data. So that's why, right, so what exactly happened, cryptography in the sense it will generate some random key. If you use a public key, when you are using this public key and for encrypting this actual file, the public key internally generates some random number, generates first random number, and the random number will be a key, and with that key it will be encrypt the data using this random key, and then after encryption you will get the secure data, and in this secure data along with your actual content, this random key also will be passed. So you can see that this one is encrypted key, this one also will be there, because if I don't pass this encrypted key, right, how the way the process for generating the random key, this can be easily understood by the private key. So along with this data, you can see the data along with this key, encrypted key using receiver's public key. You can generate one file. That file is a combination of data and your random key. We can call it as an encrypted message. Since we encrypted message has along with the key and actual content, when it is passed to the receiver content, right, where it's encryption and decryption is vice versa operation. Once you encrypt, it's a reverse operation of decryption. That for decryption, basically you'll take the same encrypted message, and this encrypted message will be, from this encrypted message, the private key can able to segregate the encrypted key. From this encrypted key, this data would be this encrypted again here, right, whatever the key generated, this key also encrypted here. You can see that the one you see and you can see is different. Means again for security purpose, whatever the random key generated, the key also again encrypted along with the data. Both will be part of an encrypted message. And when it comes for decryption, first you'll be extracting the key, and the key will be again decrypted using the private certificate, and then using that key, this data would be decrypted. Then you will get the actual content. This is how basically what encryption and decryption will be there. But now usually the real-time scenarios, what happens, right? So let me just real-time scenarios, what happens, right? You are a Bhumi, maybe I can tell you that you are a Bhumi, let's say we are a Bhumi, and let's say we are an end user. Okay, this is a one end user. Maybe you can say it's kind of an outbound scenario. It means Bhumi will be extracting some data. Bhumi is extracting some data, and this is maybe client. Okay, or client, maybe let's say the client, maybe we are pushing the file to an SFTP or something like that. Okay, so when we send this data to SFTP, the client may ask you that he wanted to encrypt the data. You want to encrypt the data. Encrypt the data. Instead of you directly sending a plain file to me, you encrypt the file and then push encrypted file to my SFTP server. Then what exactly we think when you're using encrypting or encryption means, basically what we need is we need the public key. We need the, maybe we can call it as a client as a something spelling mistake is there. Okay, client as a, we can call it as a X. Okay, we will refer client as X. So we need the, if you want to encrypt from Boomi and send it to an X, right? So this one basically X should be able to again decrypt it. If X should be able to decrypt, in the sense X should have the, what X should have the private key, because this is the only one person can able to decrypt, only one person can able to decrypt it. Who will be having the private keys? Generally whoever generates a private key, only the private key will be, whenever you generate a key pair along with the public key, private key will be generated. You cannot generate only the public key. You can generate the private key. Private key can contain the public key. So it means if a Boomi want to encrypt a file and send it to an SFTP server for X client, so what Boomi person developer need to ask is, Boomi need to ask, you give me the your public key. So then what will do, X client, right? X client what will do? He will extract this public key. Okay, he will extract his public key. He'll extract his public key and give it to the Boomi. Public key from private key, so that this public key can be again imported to, this public key can be imported in Boomi. This public key can be imported in Boomi, and using this public key, Boomi can encrypt and push the file. Okay, let's say reverse operation. Okay, let's say reverse operation. Reverse operation will be, here will be an inbound operation. Okay, inbound operation. In inbound operation, what exactly we will be having is, this is client X, client Y. Okay, now let's say client Y. So you may be connecting to client Y SFTP server, and you will be pushing the file. You will be pushing the file to Boomi for the further processing purpose. So in that case, what exactly you are going to do is, you need to do the decrypting message. You need to decrypt the message. If you want to decrypt the message here, in the sense, what exactly Boomi need? Boomi need the private key. Boomi need the private key. It means whoever has a private key means he should generate the key pair here. Whenever here in this case, client need to generate a key pair here. Key pair, and client will give extract the public key and give it to the purpose whoever want to encrypt it. In this case, encrypted and send it. Okay. Now client Y want to let's say Boomi will going to connect to the SFTP server and is going to decrypt the message, and then he'll be processing, maybe inserting the data into a database, or it might be pushing the data to a Salesforce or SuccessFactors, something like that. In that case, if Boomi want to able to decrypt it, Boomi should have the private key. When you have whoever has a private key, basically they will be generating the key pair. So when you generate a key pair, if you want to decrypt the message, in the sense, it means your input basically should be an encrypted message. Your input basically, as I explained here, right? If you want to decrypt here, your input would be an encrypted message. If you want to encrypt here, your input would be a plain plain, you will get the encrypted message. Vice versa, for decryption, you will get the encrypted message and you will get the plain data back. If you don't, basically this is called a symmetrical conversion. Means once you encrypt, after your decryption, you should be able to get the same data what you are originally encrypted it. Okay, now it means we need to have the encrypted data. If you want to encrypt by the client Y and make the file available in SFTP, what we need is Boomi need to extract the public key. Boomi need to extract the public key, and Boomi need to share this public key to the client, and this client can use that public key, Here it would be a Boomi public key here. Boomi public key. Here, first generate the private key if it is not there in Boomi, and then extract the public key, and the client Y can use this public key and he can generate the encrypted message using this public key, and then he can make the file available in SFTP server so that Boomi can connect to the SFTP server and he can decrypt it, and then he can process the message. It means whoever want to encrypt it, he need to get the message from their counterparty. We need to get the public certificate from the counterparty. So whoever need to receive or decrypt the message, he should generate the private key. It means a key pair. That's a basic thing. You want to encrypt, you should have the public key. You want to decrypt, you should have the private key. Private key in the sense, whoever has a private key is not meant for sharing, so that you will be generating the key pair. You will be keeping the private key with you. You will sharing the public key with all your vendors. So now we'll see how to generate and how to encrypt this one. Okay, we'll see both the cases. Okay, we'll see both the cases. Let's see whether my database is not there. Hold on a second. Let me start my database. So it's not like all projects will use this encryption. Few customers will use, few customers will not use that. Let's say okay, this is the one table we were using. Okay, now let's go, and first thing is we will see this outbound one. Okay, sorry, first we'll see the outbound one. Okay, for outbound one, what we will do is we will just first generate a key pair, and make this file. We extract the public key, and using that public key, you can extract the data from DB and then encrypt that public key and send the file, generate the file. So let's see how to generate the file. First is, let's generate the private key here. Change this connection to certificate. Okay, this will fall under certificate. So what we are telling here is PGP. This is the one. This certificate is used for whenever you are using for transport communication. Maybe you might be using the HTTP protocol or HTTPS protocol, maybe for web services, REST web service or SOAP web services. Then for security purpose, you can see HTTPS in the sense here, security here. This is for security purpose, connection is secure. In that case, you will be using the certificates. This is for transport level security. This is for encrypting the data. Now let me change this particular folder to demo. Now let's say, maybe let me generate something client X. Okay, let's say client X certificate. I'm just talking about this outbound. Okay, now let's create it. So when I say create it means you're just creating a certificate component. Whatever the certificate you are going to generate, right, either the private key or key pair, it will be held in a component called certificate component. As of now, it's just a component. Okay, it doesn't have any public or private key, neither key pair. Okay, you are going to now generate it. Since we don't have anything, as I says that we are going to discuss about this scenario outbound. In this case, if Boomi want to encrypt and send the file, First we need to have the public key from the client X. Since we are assuming that we are client X, what we are going to do, we are generate the certificate and we will extract the public key. In general, in real time, you just need to ask your counterpart. He'll extract the public key and he will give it to you. You just need to do that. Okay, I'll show you both the process. Now you click on generate here. So maybe identity is something like kind of an user ID. Okay, generally the thing what we will use it, you have mentioned unique ID for identifying the certificate. So we will use maybe email ID will be a unique ID field. So let's say it's not mandatory that we need to use email ID. We can use anything. Maybe something like client X something I'm using. Passphrase is kind of passphrase is something like password. We'll use something like CLIENTX, something you're using. So DSA is a kind of algorithm, cryptography algorithm. Always you can use RSA. RSA is more stronger or secure than the DSA. And you can use the number of, as you increase the number of key length, it will be that much secure. So okay, now I'm just using whatever it is there. I just copy pasted here the password as well and okay. Now you can see here generate private key. Enter the following information which will be stored in the certificate. As I mentioned that when you are generating a private key, in the sense private key can hold, or from private key you can extract the public key. Okay. So now let's click on OK. Generating PGP certificate. Okay. You can see key properties. From this certificate, now client X is a component, PGP certificate component. This component is hold, or we created a component certificate called private certificate. We created, you can see the private certificate. Key ID is just for internally to use this for identifying the number of keys. So there is nothing we will do with this for key one. We need is what type of key it is one, what is the user ID, and maybe generally it's mentioned as a vendor name, and issued on, as I mentioned, right, public and private key will be uniquely identified with the value called fingerprint. It's something like hexacode something is there. So this is a value. Now let me extract. This is the one generating the certificate or key pair or private key, whatever you can say. Okay. Now we are exporting the public certificate from here. Okay, now public certificate is exported, and generally it's used as a naming convention called PUB. ASC is asynchronous something kind of certificates will be there. Okay, so now it's exported. Okay, now what I need to do is I need to query the DB here. Need to query the DB, and I need to generate some different files, and generating the file into local system. That till that part we already done everything. But the only thing is, instead of directly generating a file, first thing is I am incorporating the logic called encryption, then I'll generate the file. So that I'm going to use a old process what we did earlier. So now I do have you can assume that this certificate might have been received from your client, and you are now ready to implement the encryption. Now let me just go ahead and db2 file. Okay, now we can do the encryption and decryption basically in the data process. The data process, we do have an option called encryption. You will see PGP encrypt. Okay, for PGP encrypt, what we need to have is, first thing is we need to import a key. Okay, we need to import a key. If you want to import a key, what we will do is, in this case, since we already have in our repository itself, we have the private key. Even we can use private key internally has a public key also. Since we can use this one as well, but I'll just show you how we can use the import option here. Demo certificate PGP client X. Yes, I mentioned something like PGP. Okay, now click on create. It's just a component. As of now, we didn't have anything. Now we can use import. We'll already have this one. Let's go ahead. What type of certificate you want to import? Public certificate I want to import. So where is this? P client something. Okay. Now click on finish. You can see what type of public certificate you are using. Public. We already know that this is a private certificate, this is a public certificate. From this component only we extract a public certificate and we created this particular component with the same exported public key using the import wizard. Now let me see whether the same fingerprint is same or not. As I mentioned, public key and private key will have the same fingerprint. Okay, copy. Okay, now control F. Okay, public key, this one is matching whatever I copied it. Now click on enter once again. Yes, you can see that. So if something like the why we use fingerprint, right? So there are the cases you might have received some public key from your vendor and you encrypt it and you send it, but your vendor is not able to decrypt using his private key. In that case, whether you can see whether you are using the right public key corresponding to the private key customer holded, you can correlate with this fingerprint. If the one public key and the private key both has two different fingerprint means you are not using the same key pair thing. You are using some different. This is one easy way to we can use for fingerprint for identifying that. Okay, now we already have the public key is there. Now I can incorporate the encryption logic. Go to the process, data, use the encryption, encrypt the certificate. You can see now this is a public certificate. Since this is a private certificate, this is a key pair, the private certificate internally have the public certificate as well. So whenever you specify encryption, it only listed out only the public certificates. It only listed the public certificate, not the private certificates. Means now the private certificate internally have the public certificate also. It will show you the all public keys. But when you say decrypt, right, it will only show you the private key. Only show you the private key. Public key cannot contain private key, right? So that's why public keys will not be visible when you specify the decrypt here. See, when you say specify decrypt, you can see only, you don't see pub1 because private key can contain both public and private. So when you decrypt it, basically decryption is required only private key, so that it will filter based on the private keys only. The public key what we already have, it's ignored it now. Okay, we are using public certificate. So now let's click on this one. Okay, whenever you are generating a file, right? What basically we use for a file naming convention. For naming convention, what we will use along with actual file extension, we'll use something like .pgp. Just as in just naming convention. After your decryption, again your file name will be, you remove this extension. To just identify this .pgp in the sense it's an encrypted file. Okay. Similar thing is you can do the let me align properly. Okay, now click on test. Select local item. Since we are doing an outbound operation, we will be expecting the public key for encryption. So we use public key for encryption using the data process PGP encrypt option. We encrypted this and we will be sending this one. So I just only encrypted here. Okay, now you can see the content after encryption, how it looks like. We have the PGP version and all the things will be there. And after PGP encryption, you will see the less size also file. So begin PGP message, encryption message. And before that, you can see that how actual data looks like. Okay, this is actual data. Similarly, you can see the how encrypted XML message looks like. After generation, right? If you see the XML file size after PGP encryption, you can see it's kind of a compressed file. You'll see the size, less size, you'll see the encrypted file. Similarly, you'll see so you don't see any kind of a difference, like whether it's a XML, CSV or JSON or any other things. You just do some kind of encryption things. By looking at the file, you will not be able to do. By looking at the encrypted file, you will not able to know what kind of file content inside it is there. So what you can do here is you can use, maybe you can generate one more key here. In this case, you would be generating the, let's say you are going to use the Boomi inbound operation. Boomi sort, something like that. Generate Boomi. This is how you generate, and you will export your public key, and you will share this public key to your ex partner, your client Y, and you will ask him to encrypt the file, and before placing it and available for the consuming, before available for the Boomi process to consume. Then he will you'll use this certificate, the one you exported, and he will consume it, and he will consider this file for encryption, and he will make the file available so that you can decrypt it. So in this case, what I am going to show you here is, you can just, I'll add one more shape for decryption also. One more shape I'll just add it for decryption also, to see whether the content is same or not. But this is how basically we'll be using it in the real time. Okay, so now I'm going to use client X, because this is with this one only we are already encrypting it. This is basically signing, nothing but it's just kind of an additional identification layer, nothing more than that. So we can just mention something like encryption. Encryption. You see, right, for encryption, we are using a plain data and converting to an encrypted message. This encrypted message will pass as input to a decryption, and this decryption will be able to decrypt into plain format if only if the encrypted message is using the same corresponding to private key. Otherwise, it will throw an error. So as of now, I am not using the wrong one. If you can use the wrong one, you will throw an error. You can see here, this time you might have seen the plain file might have been written here, the flat file if you see. Okay, plain file might be written. So if you see input of the decryption, shape source data for the decryption, it would be encrypted content, because it would be the process, it would be the output of the previous shape. It would be output of previous shape. If you see here, you can see the output of decryption. Okay, it means the encrypted message encrypted message was encrypted using the this public key, and the same corresponding private key was used for decryption, so that it has worked successfully. If you might have used something like other key, right, you are encrypting something, and now if you say this one, right, you will get an error now. See that. Because you are encrypting with X key and you are decrypting with something. You can see that secret key for message not found, failed decrypting. So it could not able to decrypt it, because if the secret key first is not able to extract the secret key at all in the first place, if it is not able to decrypt, because this is a secret key, some kind of a pattern, this is a algorithm will be identifying the encrypted message, and for decrypting this, so in the decryption process, it will use the same algorithm. Because the private key that you might have been used, this is the same one. From this only you might have encrypted you might have exported the public key, so that the same algorithm will be used it. So if you cannot able to extract the encrypted key, then you cannot able to decrypt the actual data. So this is how exactly we need to use a PGP encryption and decryption. So if you have time, if you want to proceed, we will explain the mail connector. You need to do some kind of a setup. Mail setup will be there for you. We'll use a Gmail as a SMTP server. Or else we can see in the next class.
Ready.
Okay, you want me to move for next class?
Yes. So
Okay.
I'll start my office today. Today it's working, right?
Yeah. Okay, we'll see in the next class. Mail connector setup.
Perfect.
Okay.
Tomorrow
Thank
by
you.
the same time I can connect you. No problem.
Okay. Yeah. Okay. Yeah. Thank you.